Hello student, if you like my video, please subscribe my channel. We have to discuss here which of the following species is paramagnetic. Carbocation, carbon ion, free radical, or all of them, none of them. So we will discuss about first ethyl carbon. I took an example ethyl carbocation. Carbocation, example of ethyl carbocation. See here, this carbon is carrying one positive charge, and here three bonds are present. See, two carbon hydrogen and one carbon bond. So each is made up of two electrons. One bond is contributing by two electrons. They will form one bond. So 2 to 4 to 6 electrons are there. Octet is not complete, so it is electron deficient. And all electrons are paired because they are forming bonds. 6 electrons are there, and they are used in bond formation. So there is no unpaired electron, so it is not paramagnetic. Instead, it is diamagnetic in nature, and it is electron deficient, so act as electrophile. Now we'll go for CH3, CH2. It's carb anion. Carb anion is electron rich species. Carbon carrying one negative charge, and total 8 electrons are there around this carbon. Okay, 2 to 4 to 6 and to 8. 8 electrons around this carbon, and that is why it is acting as nucleophile. And it is diamagnetic because all electrons are paired, no unpaired electrons. That is why we can say that it is diamagnetic in nature. For example, if it is bonded with any metal, here I took example of RMGX. So when it is cleaved during the time of chemical reaction, R negative, that is carbon ion, is formed. Okay, and that is carrying negative charge and acting as nucleophile. It is acting as nucleophile. Clear? Carbocation acting as electrophile, carbon ion acting as nucleophile. I have written since it is electron rich. Now goes to free radical. Free radical, from the name itself, it is understood that when Cl2 react in presence of UV light, there is one bond between chlorine and chlorine, and then there will be homolytic cleavage, and this bond each carry it is made by the contribution of two electrons. One electron from chlorine and this one electron from chlorine. Each will take their own electron, and they will form two chlorine free radical. It means it is having one unpaired electron. That is why we will call it chlorine free radical, and it is paramagnetic in nature. So the species which are having unpaired electron in atomic orbital are and they are independent, so they are paramagnetic in nature. Only free radical contains one unpaired electron. That is why we call it free radical, because they are free to independently react with a highly reactive species formed by homolytic cleavage. Photochemical reaction, fuel burning, polymerization, they will play very important role. So answer C is correct, that free radical